Muted it. There we go. That should be better now. How about now? Still not working? Okay, sweet. Sorry, I haven't done this in about 6 months time properly. Right. Cool. So I'm like incredibly getting distracted here on the sideline here because all I see is there's a new feature that YouTube has actually released, I guess, by the looks of it. I've got like, I don't even know how to, can I show you guys? I'll see if I can try and show it to you because it's pretty interesting. Where is it? Add source, desktop catcher, YouTube. Okay, here we go. There it is. I've never seen that before because I just got distracted. I was like, what is all of this? So, and I can see like, I don't know if you guys see this as well. That's fun. Fun times. Anyway, look. So, to answer a few questions before we get started. What is it? Burger Muncher, when will I do probability level 3? I will be doing level 3 in about, once I finish level 2, I'll get started on level 3 straight away, all right? Yep, you guys can hear me. That's all good. I was doing level 3 for like... good to hear, Rev. Yes, you are. Okay, so what we're going to be doing in this next this particular series is doing level 2 probability. Now, I've got like multiple resources with me, so I will basically be going through it fairly slowly. Burger Muncher this year. Once I finish level 2, hopefully I'll get to do level 3. Don't know how deep I'll go, but like at least I'll get some parts of it done. Level 2 tutorials, I'll start with probability, and I think maybe, what are we in July right now? Maybe in August we'll start upping the ante if I can finish a few of these, knock off these live streams. Then we'll go into normal live stream tutorials. I'm not ready to do 5 days yet, but starting off slow with 3 days, and then we'll up the ante. I think definitely by week 5 we'll go into like full 5-day mode. I think Burger Muncher, I think the main part is probability trees, but I think by the time you get to level 3, you are doing a little bit more. So I think, I don't know, like a couple of probability trees might be useful for you, but apart from that, I don't think so. Because we do spend quite a bit of time in normal distribution, right? Oh, man. All right. So in saying that, folks, we're going to get started with this probability. We'll try and run for about 45 to 50 minutes. And then depending on how well ChatGPT behaves, because I am copying questions from there. And some of the questions work, some of the questions don't, as you guys know. So we will try and go through majority of it, all right? So the outline for this particular series is we're going to do, just to give you a bit of a debrief. So we'll do a little bit of probability revision. So this is very much from what you did at level 2. Then we'll do probability trees, and then the big one, which is normal distribution. So we'll spend quite a bit of time in normal distribution. Once we finish normal distribution, we will do relative risk. So that's pretty much the outline for this particular series, all right? So just if there is any other people that are saying hi to you, and then we're going to get straight into work, people. So let's start with some basic probability revision. So one of the things is that with probability, and I always remember one of my teachers saying this when I was at school, you know, when you're doing probability, if you get an answer that's actually greater than 1, you probably did something wrong. And if you get an answer in negative, you've definitely did something else wrong there as well. Noodles, we're doing that right now. This is the part 1, like how we're doing for calculus and algebra. This is pretty much the first video of that series. All right, so things to remember. All right, your probability, when you're working with probability, you're always going to be with your answer is always going to be with 0 and 1. Or if you really think about it, when you have something like a probability of 0, that basically means it is impossible for it to happen. And then if you get a probability of 1, there's almost like it's a certain chance that it'll actually happen. So there are some key words that's worth remembering when you guys are doing probability. See you later, Rev. The other one is the 50, like 0.5. Really important that this is, sometimes people say this as 50-50 chance, and then they say 50%, but really you could also call it like equally likely. So that's another word that they tend to like to use. So that's something that you need to kind of remember as well. So equally likely. Equally likely? Am I getting this wrong? Likely, unlikely, even chance. Maybe I'm getting this wrong. Help me out, people. Help me out. I always make mistakes with probability. That's part of the reason I don't like it as much. It is equally likely. Yeah, I remember now. It's in my notes. There we go. So, all right. Now, the next thing is... so a couple of things to remember, like when you are looking for probability, we don't write probability in percentages. Usually we write it in fractions or decimals. So that, I mean, it's not wrong, but I mean, because, 0.5 is still 50%, but it's just good habit to kind of write it as a decimal or a fraction rather than a percentage, but you'll still see it. So it's absolutely fine. If you do it, it's not like you're going to get pinged or anything like that. What else? Bit more probability is, I mean, if to find the probability, you will have like whatever the event is, and then like the number of outcomes that you have. So if you think about like, if you've got a dice and you want to find probability of 2, then you know that you only get like 1, 2 out of the whole dice, but there's actually 6 numbers altogether. So that like 6 there is pretty much called all the outcomes, and then in this case we call 1 an event. And again, I could be wrong in this, but it's all right. As long as you get the idea, you're pretty much good to go. A couple of other keywords that's actually worth remembering. Usually when you're working with probability, they will use the words and or. If they use and, most likely, no, actually not most likely, pretty much certain that you're actually doing multiplication. And then if it's or, you will be doing plus. All right, so in saying that, what we're going to do is we're going to get straight into it, and we're going to try a few questions first. And what I normally do is like I kind of just leave these questions for you guys to give it a go, and then I'll go through the answers, and then we can kind of like just have a check to see how the answers come out. Now, I know this is the first time you guys, some of you will be joining me here. How it works is like usually I do a little bit of concept, and then we do some questions, and normally I try and find like exam questions for you to try and do, so you can get confident with some you're getting some achieved straight away. What I'll do is I will have a look through as you guys are actually working through this. So I'll go through the answers for this particular question in about maybe 2 to 3 minutes. So 8:12 I'll go through the answers, and in the meantime I'll see if I can find some old questions that we can pull out. It's more normal distribution than anything else. 2019. I don't think I've seen like an exact exam question with just probability. There's two-way tables. No, we're not going to do two-way tables yet. We'll probably do them in just after trees. Feel free to chuck up answers, guys, if you need to. Otherwise, I'll go through it anyway. Yeah, like I said, this is all basic stuff at the moment, so there's not much exam questions in this side yet. Now, we will speed up fairly quickly, so we'll start off slow, and then we'll kind of go through it fairly quickly as well. Yeah, normal distribution 2023. All right, so let's actually start going through these questions here. So the first one is we've got a box that actually contains 12 tiles and numbers from 1 to 12. Now we're choosing a single tile, and that's pretty much set. And the question saying, what's the probability that a tile drawn is a multiple of 4? So we know that, like I said, we've got 12 numbers here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you don't need to write all this down, but I'm just kind of showing you guys here. So what we have is we've actually got 12 outcomes. And then out of those 12, we've got to figure out which ones are all multiples of 4. So in this case, when we look at multiple of 4, we're going to get 4, we're going to get 8, and we are going to get 12 there. So 4, 8, and 12. That actually gives us 3 out of 12. Good idea to simplify it. So we're going to write this as 1 over 4. Now the next thing it says is it's not a prime number. So if it's not a prime number, what we can do is we'll try and figure out which ones are actually prime numbers. So prime number, we're going to have 2, 3, we're going to have 5, 7, 8, 9, 10, 11. Let me know if I've missed anything, because sometimes I do tend to miss it. Oh yeah, 1. How could I miss 1? You guys, not a prime number. As one's not a prime number. So 1, 2, 3, 4, 5. Yeah. Sorry, my bad. So that means we're looking for not prime numbers. So 5 of them are prime numbers. So if 5 of them are prime numbers, then 7 of them are going to be not prime numbers. So we've actually got to go 12 minus 5 for that. Okay, what about the next one? So we're looking for odd or greater than 8. So I might just have to get rid of some of these highlighters. Yeah, it's just... Now I'll just do it. Actually, no, I'll do it this way, actually. Let's go odd or greater than 8. So that means we'll have 1, 3, 5, 7, greater than 8. So that's going to be 9, 10, 11, 12. So in this case, we're going to get 1, 2, 3, 4, 5, 6, 7, 8 out of 12. Or we can actually say 2 out of 3. And finally, we've got factor of 12. So we've got factors of 12. So that means we need to see what are all the numbers that multiply to 12. So we're going to have 12 times 1. We've got 6 times 2. And then we've got 4 times 3. So altogether, we've got 6 numbers. So that's going to be 6 out of 12. Or we can actually say that's going to be half. All right, so that's pretty much question 1. Now I've got a couple of more questions like this, and then I'll ask you guys how you guys going. And then we can go from there. Awesome. Now you can actually just write it as a fraction or a decimal. It doesn't matter. Sorry, I forgot your question. Awesome, because I did see that you had a question. Is that your question, or did you have a different question, mate? Oh, this is the 12th birthday one, eh? Awesome. I gotta make it, man. I gotta make it sometime this weekend. Yeah, I've got to make it first. I got sick on the holidays and I didn't get a chance to actually do any t-shirts. But now I'll do it this weekend sometime and then I'll get it through. All right, so second question, guys. So we're still working on those same 12 tiles. But this time, easy, awesome. See you later. So just to keep in mind, like in this case, they're doing something called without replacement, all right? So that means, now you got a bag. Now in this bag, you've got, was a bag or box, whatever it was, right? So bag of 12 tiles. So what happens is it actually says that it's without replacement. That means when they take a tile out, for your second tile, you've only got 11 tiles actually that's actually left over. So keep that in mind. So when they take the first one out, for the first tile, they've actually got 12 options. But when they take one out, they're not actually putting it back into the bag, which means the second option, they're only going to have 11 tiles. So if that's the case, just keep that in mind. And also, this is 2 tiles, so that means you've got to multiply both the probabilities. But I'll tell you what, I'll give you guys a couple of minutes to try it out, and then we'll go from there. Yeah, it's only like 8 years in the making, Jack. All right, so I'm gonna start doing this slowly now, so you guys can keep an eye on the answers here. So for question A, what we've been asked is, what is the probability that both tiles are actually even numbers? Hey, Sugneed, welcome, mate. So if we look at it, we've got numbers going from 1 to 12, and so first we need all the even numbers. So if we list down all the even numbers, so even numbers, you're going to get 2, 4, 6, 8, 10, and 12. So those are your even numbers. Now, what you have is for the first one, right? You've actually got 6 out of 12, because you've actually got 6 even numbers out of the 12 options that's actually available. But when you actually get to the second one, because we actually want both tiles to be even, so when you look at the second one, because we've already taken one tile out, we no longer have 12 tiles. We actually have 11 tiles. And remember that when we actually take one even out, we've only got 5 evens that are actually left over. So because of that, we're going to get 5 out of 11. And because we want both tiles are even numbers, so tile 1 and tile 2, and remember what we talked about earlier today, was that when we have and, we do that multiplication. So in this case, we can actually say, right, the first one is an even number, and the second one is also an even number. So we're going to multiply the probability, and what we should get is we got 30 over 132. And you can simplify it, and I think you're going to get something like 5 over 33. So that's what you're getting for question A. Question B, what we have is we want to have one odd and one even. Yes, Sammy, this is probability, level 2 probability. We're just starting with this at the moment, and then we'll start ramping it up fairly quickly. But I just want to get through the basics, so we cover all the basics first. Okay, so when we do one odd and one even, now remember that there's actually two situations that could actually happen here, right? Now, the first situation is your first tile could be odd, and your second tile could be even, or you could actually have your first tile is going to be an even number, and your second tile is going to be an odd number. Hey, dang. So let's have a look at it. Now, if you want to have odd numbers, now we know 6 of them are even, which means for odd, you are going to actually have 6 out of 12. That's for odd numbers, right? Now, if your first one is 6 out of 12, for your second tile, you've actually got 11 left over. But out of that 11, 6 of them are even. We're not doing odd. Now, if it was odd, then it'll be like 5 over 11, right? But because the first item we took out was an odd number, we still got 6 even numbers left, and so therefore it's going to be 6 over 11. So in this case, we are going to get 6 over 22 as one of the probabilities. But the other situation that could happen is you could actually have even number come first. So if even number comes first, you're going to get 6 out of 12 multiplied by, and then you got to have a look at how many odds that's actually left over. And you've got 6 odds out of the 11 that's actually left over. Once again, we get 6 over 22. Now, remember that these two situations could happen. So basically, that means it's an or. So you could actually have one odd and one even, or one even and one odd. And because of that or, we actually have to add the two probabilities together. So we're going to get 6 out of 22 plus 6 out of 22, which is going to be 12 out of 22 or 6 out of 11. So the probability of getting one odd and the other one is even is going to be 6 out of 11. All right, so the next question is find the probability that both tiles are prime numbers. So if you go back in the previous example that we did, we found that from between 1 to 12, all the green highlighted numbers, they are prime numbers. So prime numbers, there's actually 5 prime numbers between 1 to 12. So when we get to question C, so it's saying find the probability that both tiles are prime numbers. So once again, we're going to do our first and second. So our first one, we've got 5 prime numbers out of 12 multiplied by the second tile. So when we do the second tile, we've only got 11 left over. And because we picked a prime number out already, we're going to have 4 prime numbers that's actually left over. Now we got 5 over 12 times 4 over 11. What's that? 1 over 3, 1 over 3. So we're going to get 5 over 33 as the answer for question 2 there. So I'll pause for a couple of seconds. If you do have any questions, feel free to put it up in the chat and I'll answer them. And then if we're good, then I will continue on with the next question. I'll give you a minute to just take that in. Okay, we're quiet. I'm assuming that we're all good to go here so far. So, all right. So next thing. No questions yet. All right, next question is this one here. And again, I'm going to give you folks maybe about 3 minutes, a minute for each of these questions to give it a go. And then I will go through the answers. So we'll go through the answers at 8:29. And in the meantime, I need to talk to ChatGPT to get some more questions. You know, for the people that are actually on the chat, like, have you guys started this topic yet, or are we still doing algebra and calculus? It's a very quiet group. Oh, you started today. All right. Well, we'll race with your teacher to see who finishes faster, eh? Are you guys using the Walker Maths book? AK, what topic are you guys working on? Yeah, I've got a license from Walker because I was gonna use the Walker Maths book and use that, but I looked at the book and I was like, oh man, the amount of cut and pasting I need to do onto the OneNote is just crazy. Anyway, AK, you do know about the level 2 calculus in 10 hours playlist, right? And if you haven't heard of it, go check it out because we did that last year and it was still pretty valid. Okay, so for this question here, what we've got is we've got spinners, right? So spinners divided into 8 equal sections, so 1 to 8. So equal sections, so that means 1 to 8, so that's fine. Find a probability that the spinner lands on a number less than 3. Now it's really quite annoying when it comes to probability with the language, all right? So you've got to be mindful of it. Less than 3 means that you want 1 and 2, but 3 is actually not included in it. If they say at most 3, then 3 is included. If they say at least 3, so let's just kind of put that down here at the side here, right? So less than 3 means you're doing 1 and 2. At most 3, you're doing 1, 2, 3. If you do at least 3, you're doing 3, 4, 5, and so on. And if you do more than 3, you are doing 4, 5, 6, and so on. So that language is quite useful to kind of remember. So in this case, we're looking for probability A, for probability A. For question A, we're looking for probability of a number less than 3. Now, the way sometimes people will write it is they will write it like this. Hey, David, So see how this little p here, what this little p stands for is just probability. And the little x here, the big X as sometimes they call it, not little x. The big X is like whatever the random variable is. So in this case, we're trying to figure out what it's going to be. When we spin the spinner, what is it going to be? And less than 3 is actually written like this. Now, you don't need to know how to write this yet, but it would be handy for you to learn how to actually write it in this kind of format. But anyway, we're going to do probability of random variable x is less than 3. So that's 1 and 2. So we've got 2 out of 8. And because it's 2 out of 8, we can say that's going to be a quarter. Next, we look at B. So with B, what we've got is find the probability that it's a multiple of 3 or 4. So we're going to write down all the multiples of 3. So that's going to be 3 and 6. Write down the multiples of 4. So that's going to be 4 and 8. Don't ask me how to write this, but I'll probably write, say, probability of x. How would I write it? It's a multiple of 3. Yeah, see, this is why I don't like writing this. I'm just going to write, let's just write probability. Probability of multiple of 3 or multiple of 4. So that's going to give, that is 3, 6, and 4 and 8. So we've actually got 4 out of 8 as the options, and that's going to be a half. And finally, looking at question C, find the probability that a spinner does not land on an even number. We have got 4 odd numbers, and because we have 4 odd numbers, we can actually say probability of odd. But the other way of writing probability of not even is you can write it like this. You can actually write down even and then put a little dash above the even. So basically that means not even. So if I say like probability of A, and then if I want to say probability of not A, I would actually write it like this. So this is just like the opposite of that probability. Anyway, probability of not even. So we've actually got 4 numbers that are not even. So once again, we're going to get 4 over 8. And that's equal to a half. All right, now I'm going to pause here and I'm just going to ask you folks here in the chat here, do you want any more questions like this? Or are we happy? We're ready to move on to probability trees. Let me know. Sometimes, usually even 1 or 2 gets me an idea that we can actually move on or not. And if you're going to be quiet, then that's fine. I can actually move on too. Oh, okay. Well, no problem. Ooh. I wish I knew how the answering schedule works, because it's like some of the reports that you guys got for outcome 1, 2, 3. I like try to understand it and I'm like, man, this is hard. I don't understand it. I wish someone could teach me that. All right. Thanks, David. We will move on. So with probability trees, what I'm going to do is I think I want to do question 2. Because question 2, the reason I'm coming back to question 2 is because question 2 is pretty much a probability tree. And I want to show you guys how we did this answer here as an intro to probability and probability tree. And then later on, what I might do is I might see if I can get a couple of questions and then go through with probability trees, all right? So let me just see if this is going to work, because this is a little bit annoying, but let me try. Copy. Man, this is so annoying. Come on. Sorry, folks. Give me a second. I just need to fix this. Control C, Control V. Nope, Control Z. There we go, that's a lot better. Where'd the question go? All right, so this is a really good example to kind of showcase this probability trees intro to, right? So in this question, we've already done it. We actually figured out what the probability of the two even numbers were. And I think we got it as 5 out of 33 there for A. Why are you playing up? So how this is going to work is like this. So let's say we are going to draw this as two branches, right? Now in this one, all we have is we've got even numbers or odd numbers. So we're going to put a little E here for even numbers and O here for odd numbers. And if I'm correct, we had 12 tiles to start with, and they were numbered from 1 to 12. So because there were 12 tiles there, sorry, just write that a little bit better. When it came to even, we had 6 out of 12 tiles that are even and 6 out of 12 tiles that are odd. Now, here is one of the first fundamental rules about probability trees. When you split into two branches, or like when you have any kind of branches, the branches must always add up to 1. So if you look at this, this is 6 out of 12, this is 6 out of 12, and when we add up both 6 out of 12 plus 6 out of 12, and I'm going to do it in the calculator, I know I don't need to, but I just wanted to show you guys. So 6 over 12 plus 6 over 12, we're going to get that as 1. So it's really important that, and this is important because like when you guys get to your exams, what happens is that they give you only one branch and they'll give you the other branch as empty. And if the other branch is empty, what you got to do is you just got to go 1 minus whatever the probability of the other branch is to get this probability. Now, this is for the first tile. When we go to the second tile, what happens to our tree is it kind of continues. But this time, it's going to continue from two different spots there because it's going to continue from even and it's also going to continue from the odd as well. So here we are going to have even and odd. So let's actually do this first. Because we've actually got rid of one of the tiles, we only have 11 tiles left over. And out of the 11 tiles that's actually left over, we took an even, which means there is only 5 even left over. And on the other side, we've actually got 6 odd still left over. Now notice this, if you add up 5 over 11 plus 6 over 11, you get 11 over 11, which equals to 1. And again, your probability is adding up to 1 for the green part. This is another quick way to, they will again do this where they'll just leave like a branch empty. Finally, if you go to the second set of branches, you're going to get E and O again because even and odd. But this time, we still got 11 left over because we took the first one, which is an odd. So we're going to get 6 over 11 or 5 over 11 for odd. And once again, you would notice if you add up these two blue probabilities, they are going to equal to 1 because 6 over 11 plus 5 over 11 is just 11 over 11, and that's 1. Now, the last part that I wanted to show you guys with a probability tree, and this is sometimes people don't do this, but it's actually worth doing it. And this is many thanks to Mrs. Edwards from Selwyn College, and back in 98 or 99, she taught me this. But I'll tell you what, it's pretty handy. So what you tend to do, what she suggested at that time was this, write down your outcomes. So this is going to be even and even. This is going to be even and odd. This is going to be odd and even, and then this is going to be odd and odd. So these branches here, that's what their final outcome is. Now, as for the probability itself, what you need to do is you kind of need to work them out. So for the E and E, we've got 6 over 12 times 5 over 11, which gives me 5 over 22. For E and O, so let me just get this right. Hang on. I want to show you guys this. So this branch here, that color is not suiting. I want to show this. How do I show this without? Yeah, so basically it's this particular branch here, that's the orange one that goes through there. Then we're going to do the pink one, which is, oh, no, I don't like any of these things. I think you guys can see, right? Like, let me just go. Hey, Joe Channel, welcome back. So EO, that's even and odd. We're going to get 6 over 12 times 6 over 11. So that's going to be 6 over 22. And then for odd and even, we're going to get 6 over 12 times 6 over 11. This is 6 over 22 again. Finally, the bottom one, which is 6 over 12 times 5 over 11, which is 5 over 22. Now, what you should notice is these numbers in the red box here, they should all add up to 1 as well. So if you look at the numbers, you've got 5 over 22 plus 6 over 22 plus 6 over 22 plus 5 over 22. This is 22 over 22, which equals to 1. So this is basically telling us that your probability tree is correct everywhere. If your probabilities don't add up to 1, then you know that you've done something wrong with the probability tree. So this is like a bit of a shortcut for you to kind of see whether your probability tree is actually correct or incorrect. Now if you actually go back and now if you go back and have a look at the actual questions, right? So question A there. Question A was find out what's the probability that they're both even numbers. And we did find that out because that was 5 over 22. And if you go back right at, did I say 5 over 22? Did I make a mistake earlier? I think I did make a mistake here. That should have been 22. No one said anything. Thanks, guys. So yeah, that should have been 5 over 22. And then the second one is like, what's the probability that one of them is odd and one of them is even? So that is going to be one of them is odd and the other is even. So it could be EO or OE. And when we add these two up, we get 12 out of 22. 12 out of 22 is 6 over 11. And if you go here, we actually got that answer there. So hopefully you guys can see the connection between the two of them. Hi, Sophia. Welcome. Yeah, this is July. We start the work. All right. So what I'm going to do is let me know if you have any questions about this one and what I did. And I might just give you folks like one practice question to try and do. And then what we'll do is we'll probably call it after that. And then we'll come back again on Thursday to kick off part 2 of this. But let me know if you have any questions with this. If you don't, I'll see if I can find a question for you guys and we'll go from there. I mean, I can't believe you're real. I am real. So that's the craziest thing I've ever heard. Well, what school do you go to, Sophia? Actually, are you in Auckland or? Sync this notebook, come on. All right, I'm assuming that you guys have no questions with this. I'm just syncing up the file, which takes stupidly long. Just loading a question. Hey, Nish, welcome. Oh man, where's my question? Sync. There we go. This is our final question for the night. I'd like you guys to try and do this in a probability tree. Give it a go, and then I'll go through the answer. I'll give you folks maybe a couple of minutes to try and do it. I think 3 minutes should be more than enough. Joe, when you say live streams, you're talking about the full topic, like 15 hours. I already did that last year, man. Well, actually. But we'll do revision ones later. Like when you're ready, like, because I've still got some horrible exam papers that I picked up from, there was this company that used to make some really tough questions. They gave me license to make videos, and they are some tough questions. See, I don't understand this top fan thing. It's like you guys all get experience for something, but then how come you all stuck on 75? Weird. So when you say live streams, are you talking about like the practice questions, or are you guys talking about the learn the whole content? Because I think I did that as a playlist so that you guys can watch it anytime. That's the 10-hour and 15-hour playlist. But definitely we'll be doing just normal kind of like batch, revision live streams. Yeah, I'll definitely do revision ones. Yeah, nah, definitely we'll be doing practice ones. I'll start probably, I'll see how long I can finish these probability ones, and I'd like to finish it quickly so we can get onto the revision one, hopefully by mid-August. I'd like to get started. Because when is your guys' mocks? In end of September or early September? I should have started this probability one last term, but I was just too lazy. Right, while we're doing that, I'm going to try and answer these questions so we can kind of finish off here. So we've got, large number of marbles in a bag. A quarter of the marbles are black and 3/4 are white. 2 marbles are drawn. So I'm going to draw this as a probability tree first, right? So I'm going to put down black and white. So black one is 1 out of 4. And white is 3 out of 4. Now, interestingly enough, this particular one, what's going to happen is, I should have actually had a different probability. That was so stupid of me. But it's fine. If we pick a black one, because there's only a quarter, like we can kind of say 1 out of 4. Did I copy the question wrong? Give me 1 second, guys. I think I might have actually copied this question wrong from ChatGPT, but not ChatGPT. Where did I get it from? Three or 5. It's a very strange question. 3 or 5. 3 or 5. Hang on a minute. I think I've got this question written the wrong way. I do apologize. I'm just trying to see if I copy the question correctly. 30 20. I was looking at the wrong one. No wonder. Hold collar. Hold. 2. Okay. A quarter of them are black. Yeah. No, it's just if it like I think the wording of this question is not right. Because for 3A, I don't like the wording of it. Like, because they've actually gone 9 out of 16. I think I know what happened with this question. I feel 2 marbles are black. I don't like the wording of this question because they should have said replace, because we don't actually know whether it's actually replacement or without replacement. Yeah. I think you're right, David. Because if they say 2 marbles are drawn from the bag, can we just assume that... We can't assume that it's a quarter, because I would have liked them to give a bit more detail with this question. No, we can't say that, David, because even if it's a large bag, right, if we take a marble out, then the probability is going to change. It will, like, let's say if there's like 5 out of 25 of them are black, then, or either they're kind of saying that because it's so large that it's going to be equal to a quarter, but it's an annoying question. I guess in this one, what they were trying to do was like this, because that'd be just a quarter. That'd be 3 over 4, quarter, and 3 over 4. Because then for white and white, that's going to be 3 out of 4 times 3 out of 4, which is 9 over 16. And then one of each color, you've got black and white, or white and black. So that's going to be a quarter times 3/4, which is 3/8. But then I get 3/8 again. No, not 3/8, 3/16. And then 3/4 times a quarter, which is 3/16. So both of them added up together, we get 6 over 16 or 3 over 8. Yeah, did you... Well, no, see, I thought it was 4 marbles, but then when I look at the question, it says very large numbers. So I guess we have to assume that they're replacing it. Because this is one of those weird, like, I'll show you what happens if they don't replace it, right? If they don't replace the ball, we would have to assume that there's actually 4 marbles altogether. So in that case, we'd actually get like 4 marbles. And this is just sidetracking here, that we're assuming that they are not replacing. Then that's going to be a quarter, 3/4 white. But because there will be no black marbles left after they pick up 1, you're going to get 3 out of 3. That's going to be white, black and white. And you're still going to have 1 out of 3 in this case, and 2 out of 3. Initially, I was thinking the question was going to look like this. But then that large number of marbles really kind of threw it off. Yeah, that's why I was stumped as well, Nish, because I went through and had a look, and I was like, huh? Why would they have this as 9 over 16 and 3 over 8? But also, I think David is on point there, because it, unless they're saying because it's so large, it's such a large number of marbles that, you know, like when you round it down, I don't think it'll matter. But yeah, I I'd be frustrated with this question, and this is part of the reason why I don't do probability that much. But anyway, guys, look, what we'll do is next time when I come back, I think it's on Thursday, we'll start with a probability tree question from an NCEA exam. So you guys can actually look at what and we'll do like a quick little question. And then after that, we'll actually do a couple of NCEA exam questions so that you kind of get the hang of it. Most of the probability tree questions tend to be merit, if I remember correctly. So it's definitely a worthwhile thing to be good at because it makes things a lot more easier. But yeah, apart from that, thank you for today. And I know I kind of got dragged on at the end. I apologize about that. It's just one of those annoying questions that always seems to pop up every now and then. But yeah, I'll hang around for a couple of minutes, and then if not, thank you for joining today. Appreciate it. Pack up time. Nish, no, that was not an exam question. That was actually I found it from an old textbook, and that's why I was like, what the hell is happening here with this book? No worries, Derek. You're welcome. Easy, David. So part 2, we're doing, just need to write notes down so that I remember. Oh no, I've added too many things. Yeah, have a good night, Chris. You too, AK. I don't know who the top fan is right now. Who's the top fan? This is fun. Like, I'll show you guys what's happening here. Desktop capture. Live streaming, here we go. Yeah, I don't know what this top fan thing is, but none of it, there's no movement happening here. I thought you guys would move. All right, anyway. All right, guys, take care, and I shall see you on Thursday. I will set a link up very shortly for Thursday's one. Yeah, and please just let people know that we are doing this very slowly. And thank you for your support. All right, till the next time, catch you later. And as always, thank you for watching.